In this video, we're going to talk about multiplying rational expressions. Now, the first thing you need to really come to terms with is, when do you know a rational expression is simplified? So when is a rational expression which you guys know is just really a fraction, right? A rational expression is just a fancy way of saying when is a fraction simplified. All right, so before we multiply, we got to know when we have a simplified fraction. So the answer to that question is when the numerator and denominator have no common factor. So that's going to be when both the numerator and the denominator have no common factors. So, for example, let's do a throwback to I don't know, 5th grade or something like that. So for example, if I gave you the fraction 6 over 8, now you already might look at that and just know without really thinking about it that that reduces to the fraction 3/4. But when you do that, you maybe don't really think about it, but what you just did is you canceled out common factors of 2. The first thing that you should do is factor the number. So if you did the prime factorization of 6, that would just be 2 times 3. And if you did the prime factorization of 8, that's 2 times 2 times 2. So the common factors that are in the numerator and denominator are the factors of 2. So we want to cancel those out in order to have a simplified fraction. So we really have 3 over 2 times a 2. Now this fraction, this rational expression, has no common factors. So we can just rewrite it as 3 over 4. And there's nothing else that can be canceled because we canceled the 2's out. And so essentially that's all we have to do when we start messing around with these expressions that have variables. So notice I'm just going to write out the steps that I took on the above example. The first thing we did is we factored both the numerator and denominator. Then the second thing we have to do is just cancel common factors, if there are any. So let's start working on some examples that we might run into on a quiz or a test. Let's first look at this. Let's call this example 1. Let's say we have the rational expression x squared plus 5x, all of that over x squared. Now, what some students do is they get cancel happy and they'll say, ooh, I have an x squared and an x squared, and I'll just cancel those out. The problem with that is x squared is not a factor of both the numerator and denominator. I know that because when we talk about factors, guys, the key is everything has to be multiplied to be factors. So factoring, if you think about it, is a fancy way of just saying multiplying. Okay, so you can't just do that. Remember, the first step before you cancel is to factor. If you factor the numerator, there is a GCF of an x. So if you factor it out in x from both terms, you'd be left with x plus 5. Right? Now it's factored. I'm multiplying the factor x, so this is one factor, and the other factor is an x plus 5. There are two factors, x and x plus 5. In the denominator, if I factored x squared, it's really x times an x. So I have a factor of an x and another factor of an x. Notice how these x's are common factors. So we can cancel out those x's there, and that leaves us with x plus 5 over x. Now once again, you can't cancel the x's because the factor in the denominator is x, and this entire binomial is the factor itself of the numerator. And I know that because I'm not multiplying the x to the 5. So that whole expression, x plus 5, is the factor. And since that's not the same as what's in the denominator, that would be my final answer. Let's do another example. Let's call this guy example 2. Let's try x squared minus 4x minus 12. All of that divided by x squared minus 4. Again, your first step is always to factor. So if you were good at factoring in Chapter 5, this is going to be a really simple task. If you weren't so hot at that, this is going to be a challenging section for you, and you're going to have to review some of the factoring tricks. Now I know, since I'm starting off with just a leading coefficient of 1 on that quadratic in the numerator, I can go ahead and start by placing an x in the first place of each of the binomials in the top. And then I just have to think of what are two numbers that are going to multiply to make that negative 12 and then add to make negative 4. And I know that's going to be a negative 6 and a positive 2. And remember, you can check that by multiplying all that out, foiling it out, and I think you'll get that original. Now, you may not recognize the denominator as anything special, but it's actually a difference of two squares. X is being squared and a 2 is being squared. So when you have a difference of squares, I can just do x plus 2, x minus 2. Now, once you have this thing factored, we're going to see if there's any common factors to the numerator and denominator. And notice how right here, let's see if I can circle this, right here and right here, these x plus 2's are exactly the same. So I'm going to wipe those out. The x plus 2 factors I can wipe out. That leaves just the factor of x minus 6. And remember that I can't change that into multiplication of anything. It's just an x minus 6, and the bottom an x minus a 2. And I can't cancel the x's because I'm not multiplying the x's to the numbers in the top there. So that would be our simplified answer. Oops. Let's do another example. Let's call this one example 3. Example 3. Let's say I have 5x squared y, all of that over 2x y to the third times the fraction 6x cubed y squared over 10y. Now there's a few ways you can go about simplifying this, but the way I'm going to show you is kind of a standard way. What I'm going to do is multiply these expressions together, and whenever you multiply fractions, you multiply top times top, and then we're going to multiply bottom times bottom. Now if I multiply the tops together, I'm going to multiply the 5 times the 6. That's where the 30 will come from. And if I multiply x squared times the x cubed, remember you add the exponents. So in all, I have 5 x's being all multiplied together. So I'm going to write that as x to the 5th. Then I'm going to multiply that y to the y squared, and that'll make a y to the 3rd in the numerator. Now I'm going to go ahead and move on to the denominator and multiply bottom times bottom. I'm going to multiply the 2 to the 10. That gets me a 20. The x has nothing to be multiplied with, so I'm just going to copy down an x. And then when I multiply the y cubed times a y, I have in all 4 y's being multiplied. So I can write that as a y to the 4th. Now what I'm going to do is I'm going to go ahead and try to simplify this fraction. Now I'm going to reduce 30 over 20, and that would reduce to 3 over 2. We can cancel out factors of 10 in those two numbers. Now remember, when you simplify these factors of x, you can just subtract exponents as a shortcut. So x to the 5th over x to the 1st is really x to the 5 minus 1 power, or x to the 4th. And I can do the same thing here. I can do 3 minus 4, which you guys know would be a negative 1. So it's going to be 3x to the 4th, y to the negative 1 over 2. But I don't want to leave an answer with a negative exponent. That guy has to move back downstairs. So I have 3x to the 4th in the top, and in the bottom a 2y just to the 1st, since it was y to the negative 1. And that would be my final answer. I'm going to do 2 last examples before I give you guys the self-quiz to look at. Let's take a look at the following. Example 4. Or I think I'm on 3, aren't I? Let's make that example 3. Maybe that is example 4. Oops. having a hard time here getting my examples straight. So example 4. We have 4x minus 4x squared. Actually, check that. I don't want to use that one. Let's instead do this one. Let's do 3x minus 27x cubed. I hope you're using pencil, not pen. I apologize about that. Over 3x squared minus 2x minus 1. And I'm going to multiply that guy to 3x squared minus 4x plus 1. All of that over 3x. Now, this is kind of like the last example where I have a fraction here times a fraction here. And remember, what we did the last time is just multiply top to top and then bottom to bottom. But you know what? I don't want to have to multiply the tops together because that's going to make this a huge mess. So instead, what I'm going to do is I'm going to try to factor everything first. So I'm just going to look at one piece at a time. I'm going to look at this numerator first. And the first thing I notice is I can pull out a 3 out of both terms and an x. So the GCF from that numerator is a 3x. So if I divide 3x by 3x, I get 1. If you divide negative 27x cubed by 3x, you're going to get a negative 9x squared. So that's what I'm going to rewrite the top as for now. Now the denominator is a trinomial that I'm going to try to factor. Now it's been a while since we factored one of these, and that's why I wanted to switch the example to a little bit tougher of one. When the leading coefficient's not a 1, I got a 3 here. Remember we tried to factor by grouping. So I have to find two numbers, m and n, that multiply to make the product of 3 times the negative 1, that's negative 3, but they also add to make the middle, which was negative 2. So if you forgot how to do grouping, I'm kind of going over that right now. So the two numbers that would work, that multiply to negative 3 and add to negative 2, I'm thinking would be a negative 3 and a positive 1, right? If you multiply those, we get negative 3. If you add them, you get negative 2. So that means when I try to factor that denominator, it's going to be a 3x squared to start. Then I'm going to write a negative 3 with an x, the positive 1, oops, I'm going to write just a plus 1 with an x, and then you copy down that last term, negative 1, and we're ready to kind of go by grouping. Let's stick to this denominator and kind of get it all the way factored before we move on. If you recall, what we're going to do from here is group the first pair and the last pair. And out of the first pair, I can pull out a 3x, leaving behind an x minus 1. And out of that second pair, I can only pull out a positive 1, and that leaves behind an x minus 1. Remember, the whole goal was to get those binomials to match. Since I do have an x minus 1 in each, I can pull out the x minus 1 and factor that out, and I'm left with a 3x plus 1. 3x plus 1. So you can see, that's why factoring in Chapter 5 was really important. It was going to show up again, as promised. And so let's rewrite what we have here. This fraction became 3x in the top, and then I have, oh, by the way, this guy right here is a difference of two squares. One is being squared here, and a 3x is being squared there. So I can go ahead and change that into 1 plus 3x and a 1 minus 3x. And in the denominator, I can write my x minus 1 and my 3x plus 1. Okay. Wow, a lot of work just to factor that first fraction. Now we have to go to work on this fraction. On this one, I also have to try to factor by grouping. I'm going to try to find two numbers, m and n, that multiply to make 3, that 3 and 1. So it's got to multiply to make 3, and it's got to add m plus n. It's got to make negative 4. So the two numbers I'm thinking are negative 1 and a negative 3. Those multiply to make positive 3, they add to make negative 4. So if I rewrote that quadratic, it's going to be a 3x squared to start. Then I'm going to use a negative 1 with an x, a negative 3 with an x, and I copy down that last term of plus 1. If you group the first pair and the last pair, out of the first pair, all I think I can pull out is an x, and that'll leave me with, oops, that'll leave me with the 3x minus 1. And out of the second pair, I'm going to pull out a negative 1. That'll also leave me with a 3x minus 1. 3x minus 1's match. So I can pull out and rewrite my final numerator as 3x minus 1 times x minus 1. X minus 1. And good news was the denominator of that was just the 3x. So I'm going to copy down the 3x. Whoa, so at the end of the day, I have factored everything, and let's see what we can cancel. Now, you might notice right away, I can cancel out that 3x there with that 3x down there, so that's good news. I can cancel out the x minus 1 and the x minus 1, and you might not realize, but this 3x plus 1, isn't that the same as 1 plus 3x? It doesn't matter the order, you add 1 and 3x. So that guy, this guy, matches this guy. So I'm going to go ahead and I'm going to cancel out those as well. Now, I think we're done here. I'm going to rewrite my final answer. The only surviving factors in the numerator was the 1 minus 3x, and the 3x minus 1. And I think we cancel everything out because the x minus 1 went, this guy went, and this guy went. You can leave your answer like that. I wouldn't ask you to re-multiply everything out. That's about as hard as a multiplication problem as I'd ever decide to give you. I'm going to show you one last example, and then we'll call it a day. Example, I think we're on example 5. Take a look at this guy. We have x plus 2 over 27x cubed plus 8 times 9x squared minus 6x plus 4. Okay, first thing that I would do is try to make this a fraction times a fraction. So I'm going to write that as over 1, just so it becomes easier. Now we got to try to factor stuff. There's nothing we can do with x plus 2, so I'm going to write x plus 2. In the denominator here, you may not recognize it, but that's a sum of 2 cubes. And if you forgot, there's a formula for a sum of 2 cubes. If you have a cubed plus b cubed, you can rewrite that as the product of a plus b, and then it was an a squared minus ab plus b squared. If you ever run into a cubed minus b cubed, the formula was a minus b, then a squared plus ab plus b squared. So if you forgot those sum and difference of cubes formula, you might want to keep those in your back pocket. That's a tricky one to remember. So now, the way you do this, guys, is you have to ask yourself, what's being cubed to give you the 27x cubed? Well, a 3 is being cubed to give you 27, and an x is being cubed to give you x cubed. What's being cubed to give you the 8? A 2. So your first binomial should be 3x plus 2. Oops. Then you're going to times that by, to use the formula, you have to square the a. So in this case, I have to square the 3x. That's going to be a 9x squared. Then I'm going to go minus 3x times a 2, which would be minus a 6x. And then I have to write a plus, and then I have to square that last guy. So 2 squared is 4. Okay, now I'm going to multiply all that by 9x to the second minus 6x plus 4 over 1. Now you might notice something here that's really, really nice. Everything is factored. And this entire trinomial, that ugly 9x squared minus 6x plus 4, matches exactly that ugly trinomial. So that means we can cancel those whole things out, which is great. That leaves us only with an x plus 2 in the top and a 3x plus 2 in the denominator, and we are finished because you can't factor that down any further, and they're not the same factors. So this is what I'm going to ask that you do for your self-quiz. So this is your self-quiz. I think you're going to find that these do match quite well the examples that I've just done for you. The hardest one in my mind is probably example 4, and that's because factoring the denominator is going to require you to use that sum and difference of cubes formula, the a cubed minus b cubed formula from that last slide. So if you forgot that, take a look back at your notes. You should be able to write that down and hopefully get this factored. And if you factor that, you're going to notice something really, really nice happens that makes this a lot easier. Good luck, and we'll talk about it in class.